Hello. Now we're going to have a look today at how we can use combinations or choice to help us with probability problems and to make figuring out the different options available to us a lot easier to find the probability for. So we've seen in situations where we're given a question where there are multiple different ways of meeting the criteria of a particular question, we can have to add up a lot of different probabilities from a lot of different situations. And we'll see an example of that in question 8 on page 219 and how combinations or choosing one group from another can help us. And a reminder when we're talking about choosing or combinations that we're talking about this notation that we learned here, and a reminder that you must know this formula by heart as well as its expanded form that we talked about at the beginning of probability 1, the chapter probability 1. So you must know this formula and you must know how to derive its expanded version. So a reminder of that, if you've forgotten it, you need to go back and make sure you can do it. Now, what we're going to look at is question 8 on page 219, and we're going to read it out now. A class of 16 pupils consists of 10 girls, 3 of whom are left-handed, and 6 boys, only 1 of whom is left-handed. 2 pupils are to be chosen at random from the class to act as prefects. Calculate the probability that the chosen pupils will consist of part 1, 1 girl and 1 boy. So choose 2. I actually forgot to write that down. Now, I wrote down all of the information I was given, and personally I find that level of bittiness in the English quite confusing, so I drew myself a table to try and keep track of the information. You don't have to do this, but skill in drawing tables well is a very good skill to have for the exam, so if you can get into the habit of doing stuff like this, it will set you up better for some of the exam questions where the English can get quite confusing. At least it can for me. So what I've done here is made out a table where I have left-handed people and right-handed people, and I have boys and girls. So I have left-handed boys, there's 1 of them, therefore there's right-handed boys, there's 5 of them, 6 boys in total. Left-handed girls, there's 3 of them, right-handed girls, there's 7 of them. In total there are 10 girls, and in total there are 4 left-handed people, and in total there are 12 right-handed people. So I find that easier to read. You may find the English easier to read, but I suggest when you get something as convoluted as a question like question 8 that you do something, you list out your different possibilities, whatever way you want to do it, but give yourself some structure to hold on to when they give you a big block of English like they do in question 8. Now, part 1. We're asked about the probability of getting 1 girl and 1 boy. Probability of 1 girl and 1 boy. Now, here's why we would have done this most of the time in our questions. We could have gotten the probability. This would be the same as the probability of getting a girl and then a boy, or the probability of getting a boy and then a girl. That's the 2 different ways that we could meet that criteria. And we would have, if we selected the girl first, we would have 10 possible girls to pick from out of a total of 16 students, 16 pupils. And then when we pick the boy second, well, we'd still have 6 boys, but we'd only have 15 students left to pick from. Remember, the order here is taken into account. So we have the girl was picked first, so we had 10 girls out of a total of 16. That girl has now been picked, so the second person to be picked is a boy. There are 6 boys left, and there are only 15 pupils left. Or means add. If we pick a boy first, we have 6 boys out of a total of, this is the first person we pick, so 16 people. And there are 10 girls for our second person to pick, but there are only 15 people left to choose from. So we end up multiplying this out and we get a quarter plus a quarter is equal to a half. Now, it's not that this isn't doable. You've been doing these types of questions for a while, but they can get even more convoluted to figure out exactly what order we need to take account of. And there's by using the choosing notation, we're able to do it without having to think quite as carefully. So, or this is how we're going to do it using our choosing notation. So probability of one girl and one boy equals, well, what meets our criteria, what we want out of the total. Well, let's deal with the total first. We have to pick 2 people in total out of 16. So we have 16 people. We're choosing 2 of them. That's our total. And then we want the number of ways that we can get what we're interested in here. So what are the number of ways that we can get a girl and a boy? We would have, how many ways can we choose one girl? Well, we have 10 girls to choose from, and we're going to pick one of them. And we have 6 boys to choose from, and we're going to pick one of them. And means we are going to multiply those together. So we have 10 girls and we're choosing one of them. And multiply, we have 6 boys and we're choosing one of them. That's how we can pick one girl and one boy, divided by the total number of ways that we could pick 2 people from a group of 16. And when we put that in our calculator, we'll find we also get a half. So these are logically equivalent to each other, though not at all obviously so. So again, my argument is any probability ever is what I want divided by my total number of possible ways that something can happen. So what do I want? I want to choose one girl from my 10 girls, and I want to choose one boy from my 6 boys, divided by the total number of ways that I could pick 2 people out of my total class. Now that is part 1, and I've shown you 2 different ways to do it. You need to practice this method of doing it for now. If you want to do this as an extra, it's a very good skill to have. There are some questions that lend themselves to this way of doing things, but you must practice this at the moment. Now, part 2. We have probability of one girl who is left-handed and one boy who is left-handed. So probability of one left-handed girl and one left-handed boy. Now, what do we want? We want to have one left-handed girl, well, and we want to have one left-handed boy. Well, let's deal with the girls first. Sorry, I meant to put a G here. G, B. So, my LG here. Sorry, L. Left-handed girl. Well, I have 3 left-handed girls, and I want to pick one of them. And means multiply. One left-handed boy. Well, there is only one left-handed boy, and I want to pick one of them. And this is what I want divided by my total number of ways of picking 2 people from 16. And when I put that into my calculator, I get 1/40th. And this is the only way I'm going to do this question, because this is the way I want you practicing, because you must be able to use this method, and we haven't had much of a chance to practice it throughout. Now, part 3. 2 left-handed pupils. Now, did it say anything about boys or girls? No. So we don't need to worry about boys or girls in this particular case. We've just got, we're going to pick 2 left-handed pupils. Well, how many left-handed pupils do we have from my table, or from just arguing it out? I have a total of 4 left-handed people, and I need to pick 2 of them. So I want to pick from my group of left-handed people, I want to pick 2 of them, and then my total is still 16, choose 2, for the total number of ways I could pick any 2 people from my class of 16. And when I put that into my calculator, I get 1/20th. Now, final part, at least one pupil who is left-handed. Now, at least one pupil who is left-handed. At least one left-handed person. Now, what could that mean? That could mean probability of one left-handed person, or probability of 2 left-handed people. And you could calculate those 2 out and add them up. But what I want you to recognize, because in some questions that would take a very long time if you had, say, 6 different things you had to add together, what I want you to recognize instead is that anytime we see this phrase, at least one, it means the same as the probability of 1 minus the probability of no left-handed people. And most times in an exam setting, this will be much faster to calculate than doing it out this way, finding 1 of something or 2 of it, and so on. In this case, there isn't a massive difference between the 2, but this is very much a key skill. You must be able to recognize at least 1 would be the same as 1 minus the probability of none of that thing. Now, if we argue this out, we'd have 1 minus probability of no left-handed people. Well, how many not left-handed people do we have? We have 12 of them. We have 12 right-handed people. And pardon. We want to pick 2 of them out of a total of 16 people, and we want to choose 2 of them. So that's going to be 1 minus, we put that in our calculator, when we get 11 out of 20, and we get 9 out of 20 as our final answer. Now, I'm just going to remind, at least 1 is an example of this, but you could also have probability of A would be equal to 1 minus the probability of not A. I keep harping on about this because it is an incredibly important key phrase in our probability questions. So make sure that you have this burned into your mind, that probability of at least 1, well, what's the opposite of getting at least 1 of something? It would be not getting any of it. So probability of A is equal to 1 minus the probability of not A, the opposite. And those are all of the skills we need for now.